Hello guys. So this is the first exercise of the first contest. I only was able of doing this exercise, and I would like to explain my approach. Even though it is not the best, I had some effort to make it, and so here's my explanation. So firstly, the exercise asks you to calculate all subarrays to sum all the subarrays contained in a array that add odd length. So we want subarrays of size 1, subarrays of size 3, subarrays of 5 of size 5, and so forth, as long as they fit inside the input array. And you could do this very easily with for loops and like increasing the window by 2 at each iteration. But you could also do it with DP, and that was my approach, and that's what I want to explain. However, this solution with DP is not optimal. However, with the pressure of the moment, I thought that he would fit very well, and I didn't apply the easier solution, which was in fact more efficient, and hopefully I will be able to explain why. So what I did was to create a matrix with the column and row length bigger by 1 than the original input array, and then I calculated the correct sum for each windows for each window length, and the DP formula is the following. So DP of a window size DP of a window starting at position start and ending at position end is equals to DP of a window starting at the position start and ending at the position end minus 1 plus the array, the value at the of the current of the current this is end plus the array at plus the value at the position end minus 1, and that is because the array has minus 1 elements than the matrix. So how this evolves is that we start at position 1. So window the subarray starting at 1 and ending at 1. What is the sum of it? It is 1, right? It starts here and ends here. What is the value for a subarray starting at 2 and ending at 2? Is 4. And the next 2, and the next 5, and the next 3. And when we get to the end of each window calculation, we add to a variable total. So we have added each of these elements. So next is we need to calculate the window for size 2, and the window for size 2 is equals to the value at the second position of the original array plus the value of the previous window sum. So it will be equals to this plus the previous window, which was 1. So this is 5. And here we want this array, this subarray, and what we put in here is the value that is in the second position of this subarray plus the previous sum, which is 4. So here we put 6. For 2, here what we want here is the value of the element at the 4th position in the original array plus the previous Windows size. The sum of both will give 7. And then here we will want the value of the 5th position in the original array plus the previous calculated Windows size. So this is 11. Okay. And now we calculate the window size of the window of size 3. So if the window starts at position 1 and ends at position 3, we know that its value is the position, the element at the 3rd position plus the windows of size 2. Okay, so the window of size 2 is 5 plus 2, we got 7. And as this represents the end of well, we add this value. We add this value, we add this value, we add this value, and we add this value, and we add this value. I forgot to mention. Because this is a window of size 1, we add it. This is a window of size 2, we doesn't add it, but we will need it to calculate a window of size 3. And basically we continue this process, and we have it finished. So here second position, go to 3rd. So this is, I think, 2, 3, 5. So this is 11, I think. Okay, I think this is 11. 4th position, yeah, 11. So here the 5th element, so 3, 10. And we continue these calculations. 4th position, 5, 5 and 12. Here 5, 5 and 14. And here 5 and 12, 15. I think this is correct. I'm not completely certain that I have done the correct calculations, but this is how I have solved the problem. Okay, was with DP, and by adding the values when the window size is odd. So let's go to the code and see how I've done it. Okay, nothing particularly special. This was it. So I create the array. Then I start the for loop with the window size, and I cannot skip. This is one of the disadvantages, if you can say so, is that you have to calculate all the positions, even though you only want the odd ones. So I have to calculate all window sizes, despite I just want the odd sizes. So then we start always at the position 1, and we go until the end of the window for each window size. And that is it. So we start always at position 1, and we calculate the values according to this. So we start always at position 1, and we move from there. Okay, so yeah, that's basically it. Okay, so this is the worst explanation ever, but basically I have the window size here. Then here I have the start position, and the start position starts at 1 and ends at the length of our matrix minus the window size. And we have the current position, and this current position indicates where the window size ends. And then we have our DP formula, and then if the window is odd, we we store the result. Oh, so this is why it took more time. This was why. Ah, great. So the time was better than I expected. So yeah. Also, this operation was not necessary. Haha. Okay. Yeah. I'm sorry. This was some live updates. Yeah, and this is basically it. Okay. This is the TP formula. The window. And we calculate each position. So let's see how it goes. So this was the final result. Okay. 3 milliseconds, not great, but well, it was better than my previous attempts, because I had this system out. But I was happy with the result of this solution. However, I took too much time, and maybe in another time I will do something more straightforward, especially for easy questions, so that I can invest more time in tougher solutions. So this is the big lesson of this first contest. Invest more time in solutions that are more difficult, and not in solution as simple as this one. But as I saw this the possibility of implementing a DP solution, I decided to try it, and it worked, and I was happy. So hope you have enjoyed it. And leave a comment if if you need something. Okay, so that's it.